Okay, this is a fairly straightforward impedance problem where we start in time domain, we go to frequency domain, and then they're going to ask you some for seconds back at the very end. So they're going to go way into the time domain and actually ask you about time itself. So we've got a voltage source here, V sub G, and we've got its associated current that it's putting out, I sub G. And this goes into some kind of a box that we don't know what's in there. We just know there's some load in there. And it's given that V sub G is 300 cosine 5,000 pi t plus 78 degrees in volts, and I sub G is 6 sine 5,000 pi t plus 123 degrees in amps. And they ask you to find, part A, what is Z sub L? What is the impedance of the load? Okay, or you could also say the impedance seen by the source, whatever, same thing. The impedance of this box, okay? And then they want you to just determine how many seconds, okay, seconds, way into time here, is the current out of phase with the voltage, right? Because if this is a reactive load at all, if it has some capacitance or some impedance, then the voltage and the current will be out of phase. If this were a purely resistive load, then the voltage and the current would be in phase. So we have to determine Z sub L and see what's going to go on. So we'll just, get our phasors. Transform to the phasor domain, the frequency domain. So V phasor is 300 angle 78 degrees volts, right? Then, because it's a cosine function, V sub G, and magnitude, and then the phase angle. Okay. I sub G it's given us a sine, so to convert it to cosine, we gotta subtract 90 degrees. So I sub G is 6 sine 5,000 pi t plus 123. That's going to be equal to 6 sine 5,000 pi, cosine 5,000 pi t plus 123 minus 90. So you can do the cosine you can convert sine to cosine by subtracting 90. So this is 6 cosine 5,000 pi t plus 33. Then you can do I phasor. So I phasor is 6 angle 33 degrees in amps. So now we can do part A. So Ohm's law, Z is V over I. Just Ohm's law in the phasor domain. So this is 300 angle 78 degrees divided by 6 angle 33 degrees. And then calculator is just going to tell you this is 50 angle of 45 degrees ohms. So that's our answer. That's the impedance. So the voltage is leading the current by 45 degrees because this is a positive angle. So that implies overall impedance, overall inductance. It's leaning towards inductance. It's not completely inductive. If it were 100% inductive, this would be 90 degrees. If it were 100% capacitive, this would be negative 90 degrees. So 45 is positive. So it's like halfway up, to being completely inductive. So then they want you could draw this. Yeah, you could, if you wanted to, you could draw Z here. This is Z sub L. Yeah, whatever. Not that important, really. Okay, by itself anyway, it's not that important by itself. Okay, B, how long is the phase difference? So here I'll show you two ways to do this. So method one, we just calculate the phi delta, which we really already have, but the phi delta is 78 minus 33. So the 78. The voltage has a phase angle of 78 degrees, and the current has a phase angle of 33 degrees. So the difference between these two is 45 degrees, which is really what the impedance already tells us. In other words, let's go ahead and graph that. So this is, so you've got V somewhere, and you've got I somewhere. So this is V, and this is I. This guy here is 33 degrees, and this guy here is at 78 degrees. So the difference between these is 45 degrees. Okay, it's Eli. It's the voltage is ahead of the current for a circuit that's overall inductive. Yeah, so that's really what the impedance is telling you, is this phase shift. All right, what are we doing now? So we need to get this second. So we need to convert this, if this is on the time axis, we need to convert this interval here to what's the seconds. So it's going to be a lot of funky unit conversions. So omega is 5,000 pi, and this is in radians per second in units. So we have 45 degrees. We need to get seconds out of that. So we've got degrees, we've got radians, seconds. Seems like this needs to be in radians, or this needs to be in degrees per second. Somehow we got to. So let's do that. So let's do 5,000 pi is in radians per second. Let's get that to degrees per second, and then we can, get seconds. So multiply that times, there's 180 degrees per pi radians, right? So the radians cancel, and you get 900,000 degrees per second. All right, so 45 degrees divided by 900,000 degrees per second, right? The degrees will cancel and seconds will come up to the top, and you end up with 50 microseconds. So this time interval here is also 50 microseconds. How many seconds is the current out of phase with the voltage? It's out of phase by 50 microseconds. So that's one way to do the time seconds. Here's another way. You could go, instead of just starting with the 45 degrees and getting that into time, you could go all the way back into time domain. So we can get V of G. So we have, that's already given. V of G is 300 cosine 5,000 pi t plus 78 degrees. And it's this thing is max when this is 0, right? Because when this whole quantity is 0, its cosine 0 would be 1, and it would be 300 to the max, right? So this is, we could find the peak basically by finding when this part of it is 0 and likewise for I sub g, which is 6 cosine 5,000 pi t plus 33, just taking the phasor, where's I? Right here, taking this 6 angle 33 and turning it back into time domain. It's likewise max when this is 0. This is max when this part is 0. So set 5,000 pi t plus 78 equal to 0. Set this thingy here into 0. So t of v max, let's call it, is minus 78. Solving this thing for t, minus 78 over 5,000 pi is 900,000. Note that I turned the 5,000 pi into degrees per second because the numerator is degrees. So I have to go back here and turn 5,000 pi into 900,000. This ends up being minus 86 microseconds. If you do the same thing for the current, you set 5,000 pi t plus 33 equal to 0, then t of I max is going to be minus 33 over 900,000 is minus 36 microseconds. So delta t that we're looking for is just the difference between these two. It's 50 microseconds. You could graph it if you wanted, and so on the axis, this is let's see, v is here and I. So this is minus 33. If this were microseconds units, and this is minus 86 microseconds. The difference between the two is 50 microseconds. Okay.